Welcome to Electrical Machines class lesson 11. In today's lesson, we are diving into one of the most important machines in electrical engineering, the transformer. You will learn what a transformer is, why it is needed, how it works, and the different types of transformers. By the end of this lesson, you will have a clear understanding of why transformers are essential in power systems and everyday electrical applications. So let's get started. This diagram shows how electrical power is generated, transmitted, and finally distributed to our homes. At the power station, electricity is generated at 11 kilovolts. This voltage is then stepped up by a transformer to 220 kilovolts. Stepping up voltage allows power to be transmitted over long distances with minimal losses. At the substation, the voltage is stepped down to 33 kilovolts and supplied to distribution lines. Distribution transformers then reduce the voltage further to 415 volts. Finally, the voltage is stepped down to 240 volts, which is safely distributed for domestic use in homes. Now let's introduce transformers. So, what exactly is a transformer? A transformer is an electrical device that transfers electrical energy from one circuit to another through electromagnetic induction. Its main purpose is to increase or step up and decrease or step down the voltage level of alternating current while keeping the frequency constant. You can think of a transformer as a bridge between two circuits. It changes voltage levels efficiently without any moving parts. So, why do we need transformers? When electricity is generated at power stations, it has to travel long distances before it reaches our homes and industries. If electricity is transmitted at low voltage, a lot of power is lost as heat in the transmission lines. This loss is known as I squared R loss. Transformers solve this problem in a very smart way. They step up the voltage for efficient transmission over long distances, reducing power loss. And then, near the consumer, they step down the voltage to levels that are safe for use. Now let us look at how a transformer works. First, an AC supply is applied to the primary winding. Because the supply is alternating, the current changes direction continuously. This changing current produces an alternating magnetic flux in the iron core. The magnetic flux then travels through the core and links with the secondary winding. It is this flux linkage that allows energy to be transferred from the primary circuit to the secondary circuit without any direct electrical connection. According to Faraday's law, the changing magnetic flux in the core induces an EMF, or voltage, in the secondary winding. Now, depending on the number of turns in the secondary coil, we can get different voltage levels. If the secondary coil has more turns than the primary, it is called a step-up transformer, and the voltage increases. If the secondary coil has fewer turns than the primary, it is a step-down transformer, and the voltage decreases. This is how transformers can either raise or lower voltage efficiently, depending on what the system needs. Now, let's look at the diagram that shows how a transformer works. As you can see, the primary winding is connected to the AC supply. This creates a magnetic flux in the iron core, which then induces an EMF in the secondary winding. So, the energy is transferred from the primary to the secondary winding through the magnetic field without any direct electrical connection. Now let us look at the types of transformers. Transformers can be classified in several ways based on 1. Function, 2. Construction, 3. Number of windings, 4. Supply type, 5. Cooling medium, 6. Use or its application. Based on the function, we have a step-up and a step-down transformer. Based on construction, we have core and shell type transformer. Continuation on the types of transformers. Number 3 is based on the number of windings. Here we have 2-winding and auto transformer. Number 4, based on supply type. Here we have single and three-phase transformer. Number 5, based on the cooling medium. Here we have air and oil-cooled transformer. Number 6, based on application. Here we have power, distribution, instrument, isolation, pulse, and audio transformers. Thank you for watching our channel. Please don't forget to like, comment, share, and subscribe. May God bless you.